Hello and welcome to this new video on image classification. If you haven't checked the last video, please check it on my channel. I'll also post a link in the description. In that video, we covered image classification from the project setup to model training and inference. We built the model from scratch there. However, we can avoid this and use already existing models which are pre-trained on large datasets. This is the topic of this video, and we'll see an example where we will use a pre-existing model and train it for our images and then make inferences on unseen data. So what is transfer learning? It is a machine learning technique where a pre-trained model which is initially trained on a large dataset is adapted to solve a different but related task. Instead of training a model from scratch, transfer learning leverages the knowledge the model has already acquired from the original task, allowing it to perform well on a new task with less data and less computational resources. In this video, we will use VGG16 to train and make inference on the cats and dogs dataset that we have downloaded from the Kaggle website in the previous video. VGG16 is a convolutional neural network model with 16 layers, out of which 13 are convolutional layers and 3 are fully connected layers. The model uses small 3x3 convolutional filters stacked sequentially, with a total of 5 max pooling layers placed after some of the convolutional blocks. After convolutional layers, the model has 3 fully connected layers, the last of which outputs class probabilities using softmax. VGG16 has approximately 138 million parameters. The estimated total size of this model is 631 megabytes. This model is known for its strong performance in image classification tasks and was a top performer in the ImageNet challenge. This is how we use transfer learning to build a model from an already existing one. We get the VGG16 model from Torch Vision models. We freeze the parameters as we do not want to train all parameters. We will only train a few layers that we will modify to solve the binary classification problem. For that, we update the average pool and the classifier block. With these changes, we have reduced the trainable parameters to only 65,793 parameters, and size of the model has also been reduced to 168 megabytes. Now we make a small change in our train.py file. Instead of using simple binary classifier that we built in the previous video, we will use the updated VGG16 model and run this command to start training for 10 epochs. As we can see, after only 10 epochs, we were able to achieve an accuracy of almost 99%, whereas in the previous case, our accuracy was around 80%. In this case, when we run inference on unseen examples, predictions are much more accurate. This shows how powerful transfer learning approach can be. If you liked this video, please subscribe to my channel where I keep posting content related to machine learning, data science, Python programming, and other algorithms. Thanks for watching and see you in the next video.